Hello, welcome to our Fireside chat. And I'm glad everybody's joining this. Just a reminder, we post these Fireside chats on Coursera, and the July 15th and July 29th Fireside chats are up there now, and you'll find them in the Resources tab of your course. And the recording for this Fireside chat will be up there shortly. Just a reminder about a couple of things. The microphones are muted and videos are turned off. You please turn them on. And if you want to submit a question to either me or to any of our guests, or a question about the jump videos that Carly did that I might be able to answer, please do that. But use the chat function on the Zoom meeting bar. No need to wait until the Q&A part starts. So you could submit that really anytime you want. And you can do that at any point during the session. When you send in your question, I would like to have your name and where you're coming from, where you're located. That's not a requirement. If you want to have an anonymous question, that would be fine. Sadly, the answers won't be anonymous because I'm here, so and so are our guests. But this is, I really would like to know that. I also want to, as I usually do, thank our production group for all the hard work that they've done to put this program together. Tom Arcuz was very much involved in getting the videos done and working with Carly on the jump video sessions. We've got another person involved in the production, Scott Mahler. Dustin Hampton has done a tremendous amount of work on putting this whole affair that you're seeing here today together and producing the Fireside Chat videos. And Megan Gibson, as usual, has done just a wonderful job of interfacing all the stuff that we've put together. And she's handling the Q&A. So today we have a couple of guests. There are two people here in the studio. On my immediate right is Anson Park, and beside him is Edgar Hassler. And these two guys are former Ph.D. students of mine. They were what, you guys were about a year apart, roughly?
A couple of years,
yeah. And they both have very interesting backgrounds, which they'll tell you a little bit about. And they both work for American Express, and they are involved in doing online experiments in a digital interactive world. And these kinds of things go on all the time. This is a really big deal in e-commerce. And we don't talk about any of this anywhere in the course. This is now the techniques we talk about in the course are applicable in many cases to the sorts of things that you guys do. But I thought it would be really interesting for you to hear directly from people that do this kind of thing for a living about what's going on, because every time you use your computer and you go to some website, you're probably involved in one of these online experiments. Is that a fair thing to say, guys?
I'd say so.
That lots of people do this. So with that, I'm gonna turn this whole thing over to Anson and Edgar and let them go at it. And they have some PowerPoint slides to show you and some dialogue to go with this. So guys, thank you for coming to do this. But let's get this going.
All right, sounds good. Are the slides good to go? Like Dr. Montgomery said, I'm Anson. To my right is Edgar, and we're both with American Express, and we're going to be talking to you today about some of the work we do in online experimentation. So next slide, please. So here's what we'll talk about. I'll go through, our backgrounds really quickly, some of the techniques that we do use, and then Edgar will kind of take you through some of the unique challenges and some progress we've made in online experimentation. So next slide, please. Next. So we are close buds that do statistics together. Thankfully, both employed by American Express, so we get the opportunity to work together pretty closely. prior to starting the PhD program at ASU under Dr. Montgomery, all of my previous work experience was as an acquisitions officer in the Air Force. So I had 2 tours, and they were both focused on testing. Thank you. The first was at Eglin Air Force Base, Florida, where I kind of focused on air-to-ground weapons testing. And I also had another tour with a detachment of Afotech in Colorado, where we focused on operational testing of some space systems. Education background, I graduated from the Air Force Academy in 2008, and I got my MS at AFIT immediately following that, both in operations research. I did complete my PhD in industrial engineering under Dr. Montgomery, and yeah, currently at American Express.
And by the way, AFIT is, if you don't recognize the acronym, that's the Air Force Institute of Technology,
Okay.
which is a first class institution. They have most of the student body are military officers, right?
Yeah, there's a few civilians.
Few
mostly,
civilians,
mostly
yeah.
military
But
officers.
it's a really first class outfit.
Sorry, should have clarified that.
That's okay.
Edgar, go ahead.
It's not surprising that the military guy likes the acronyms, right?
Yeah, that's true.
Yeah. So I'm Edgar. I have sort of had a career arc that has gone from sort of like web application development in through business intelligence and sort of dumped me in various data science roles. My background educationally is, I did my master's in statistics and a PhD with Dr. Montgomery in industrial engineering. And, like Anson said, we work together at American Express and we're best buds.
All right. So yeah, quick disclaimer. So the views here are personal and do not reflect the policies of American Express. Right. Another thing we're trying to do is get the following acronym popularized, which is Online Controlled Experimentation and Analysis. So we're calling it OCEAN. We thought that was kind of nifty. Right. So one aspect of OCEAN at American Express, right, we're involved in a lot of different customer experiences, customer journeys, and ultimately we want to optimize them. Right. There's a lot of ideas for potential features or even products that we may want to release. But really the only way to kind of determine rigorously what resonates with customers is through an experimentation program. Right. So we want to avoid just relying on opinion, right? Especially the highest paid person's opinion, right? We want to kind of take a data-driven, approach to making decisions and really determining what features customers like, right? If you're interested in some of the stuff we talk about, there's a lot of opportunities for this at American Express. I think there was a brief hiring freeze, but as far as I know, I think they're hiring again.
Well, yeah, I don't know.
Yeah. So if this is stuff that interests you, definitely, look, there's some opportunities to come work in this field. So yeah. So now moving into some of the common techniques that we use in online experimentation, and on the other hand, some stuff you learn, in the DOE course that you may not actually use a whole lot in this field, right? So one thing we do use a lot is power analysis, right? So we do want to be able to determine when we're planning a test or, post hoc, hey, this was the probability that we actually will detect a true effect, or here's the power that our analysis did have. Right. There's also so traditional testing is kind of conducted on a fixed horizon, right? Where you plan some sample size, you run the tests, you collect those requisite samples, and then you do your analysis, right? And you shouldn't evaluate or peak, right? It's called the peaking problem. You shouldn't evaluate multiple times along the way, right? If you do that, say stopping your test before you reach that requisite sample size, as soon as, your p-value crosses some threshold, you really inflate your type 1 error rate, right? So there's, however, when we're conducting these online experiments, if we are observing, large performance differences, we may actually want to stop early, right? So that's kind of what these sequential procedures do, right? It accommodates multiple or even continuous evaluation periods along the test window so that we can conclude a test early if we observe sufficient evidence without blowing up that risk of, making a type 1 error. Right, we've also done a lot of research in response adaptive sampling, right? So in other words, normally in a traditional test, we'd have, a certain amount of variance that we're testing, and we would split traffic evenly between them, right? In other words, each prospect or card member that's generating into the experiment would have an equal probability of being served a particular variant, right? What response adaptive sampling does is it actually dynamically adjusts the weighting to route more customers to variants in the experiment that happen to be performing better, right? So we're kind of exploiting these better performing variants. The downside is we sacrifice some precision and how well we can estimate the true performance differences, but yeah, definitely some applications for that in online experimentation. And finally, especially in low volume testing situations, we do rely on, Bayesian statistics to make, to draw some conclusions if we don't have a sufficient time window to run, a frequentist test with, reasonable error rates. So Edgar, you want to talk about some of the stuff they might be learning in the course that is less frequently used?
Get the baton.
Yeah.
Yeah, so, some of the techniques that we don't frequently use are things like optimal design. Our experiments are usually on categorical factors, and so there's not a lot that you get from an optimal design. The exception to this, of course, is that if you're doing a comparison where you're comparing a bunch of different treatments to an individual control, and you just want to come up with what's the set of things that are superior to this control, you can find an optimal design that puts more of the samples into the control group and minimizes the variance of, well, you're minimizing the A criterion. There are exceptions to when you could use optimal design, but in general, we don't have a lot of continuous factors. Another thing we don't frequently use is fractional factorial designs. Part of that is just, a lot of the benefit to fractional factorial designs is that you can handle a situation where you have, a small sample size that you cannot divide beyond a certain point. And so maybe you want to run as a fractional factorial to accommodate that. The thing with us is we're dealing with comparatively large sample sizes, even though it's binomial data. And so usually we can subdivide. And from our perspective, it makes much more sense to run the full factorial and project down to a smaller design when you can remove certain effects, as opposed to running it as a fractional factorial. But again, there's exceptions to this. If you're doing anything that requires compliance review from a law team, you need to really consider how many variants can you run. And so a fractional factorial is certainly a good option in that case. Otherwise, you spend months with your general counsel's office, and I don't think I can think of anything worse than that. The only downside, another downside with fractional factorials too is it's not clear how to run them as a sequential if we wanted to do early termination or as a response adaptive. So, and then a third thing,
Edgar, I didn't mean to interrupt you, but that's kind of a research area, isn't it?
Yes, if somebody wanted to research that,
yeah,
that would be great.
Yeah, also let us know.
Yeah.
Well, and if I happen to round up another PhD student that's interested in design,
yeah,
maybe you guys would like to get involved in sort of helping figure out what we might do.
Absolutely.
Yeah, that'd be great.
That'd be great.
Yeah.
Okay, sorry, didn't mean to interrupt. But
No,
that's
great.
actually a very interesting problem.
It is.
I see all sorts of, tangly little things on that interest me.
Definitely.
There's and I mean there's tangles embedded in some of those tangles too that we're going to get to. So
I'll bet.
another thing that we don't frequently use a lot of is model building and model selection, and usually that's just because we have a pretty good idea of a model that represents our response pretty well. Again, the exception to that is that sometimes we have covariates that are very useful in doing our analysis. So one thing that we've been looking at recently is that if you look at the total volume of users coming into the experiment, right, even before you're splitting them up, that's informative to the conversion rates. And so some of that stuff, you might need to figure out how to build a model to account for that if you want to improve the performance of your analysis. But again, that's more the exception than the rule. And then finally, we don't frequently use appropriate vocabulary. And I put here in the slide that I blame computer scientists, and then I was thinking about it this morning. That's probably not fair. If you talk to like a psychologist versus an econometrician versus me, and you ask, what's this model? We'll come up with 3 different names for it anyway. So it may be more par for the course, but it's important to know that when you're researching some of this stuff and looking into techniques, that there's a bunch of different names that mean the same thing. And it's not necessarily always clear that that's the case. So we wanted to talk a little bit about why is it challenging to execute experiments online. Our goal here is that we want to randomize which experience a person sees, but that person should have a consistent experience, right? If you go to a website and you're like, oh, I'm interested in this product, and you click and you go into it and you're like, oh, okay, that's not what I'm looking for. You go back. You don't want to all of a sudden have a different page, right? You kind of want to have your back button be what you would expect. In an online platform, this is difficult because we can't just store in a database like, oh, this is what you saw and retrieve that, just because, for large organizations, the latency required to pull that data can be too high. So one thing that we do is we use non-cryptographic hash functions to map a user ID and an experiment ID into a space of uniform. It has a pseudo-random distribution, so it looks very uniform. And then we use that to determine where we should what variant we should show that person, what treatments they should get. And so there's a lot of challenges related to that. Another thing is people's behavior. People using a website will surprise you in very many ways. They will revisit the site multiple times. They will enter at different points. They will use different devices as they're accessing it. And sometimes they'll send links from one device to another. So, you'll have somebody on an iPhone just appear halfway through your process. It's not necessarily clear that it's the same person. And, one thing that's sort of interesting for our work, you even have an adversary who's trying to game the system because they want a particular deal, because there's a whole Reddit channel committed to American Express. It's fascinating to check out. Another challenge is privacy and compliance. EU privacy laws are very strict and very vague, and it is terrifying to try to navigate that. And again, you end up with general counsel's office time. And another thing is a lot of vendors in the United States, I guess they're international vendors, but companies like Mozilla and Apple, they're pushing more for user privacy as well. So, one thing that we're seeing is that when you visit a website, there's a string called your user agent string that tells you, hey, this person's using this browser on this operating system, this version of it. They're moving to get rid of all of that. And that can be very difficult if you're wanting to sort of segment your population based on that information and say, like, was this person on, an iPhone? Was it an iPhone? I never know what the current iPhone is. I'm going to say 13. Was it an iPhone 13 or was it an iPhone 5? Was it an iPad? Was it somebody using Safari? Was it, all of that information will be gone. So that can be a real challenge. Another thing too, when you imagine running experiments in an industrial setting, you run the experiment, you get the data, you make a decision. If it's a decision that you found some improvement that you want to roll out, then what you then have to do is retool all of the factories and retrain all of the people, right? For online experiments, all of the work is done up front. You need to basically build the website the way that you want it, or the app, and then you test it. And if you found one that works better than the existing situation, you basically just flip a switch and delete everything else. And so the development costs are all front loaded, and that can make it challenging to convince leadership that it's worth investing into these experiments. The other thing too is for these developers, it's incredibly difficult to maintain these simultaneous versions, right? if you imagine like every experiment that's going on, right, we're now taking the Cartesian product of all of these, and we want to be able to run them all in, in a reasonable way. So, if you have people running just a simple, A, B experiments where there's 2 levels, and there's 5 of them going on at the same time, right? That's 2 to the 5, which is a number that I'm not going to try to calculate now. And that's
it's 32. It's a big number.
32. So let's say 6 experiments, so it'll be 64. That's even bigger. So when you're doing that, all of a sudden you get a note from compliance that says, hey, there's a law that's going to go into effect in California about consumers' rights. We need to make sure that we add this note in there. You need to add that note to 64 different places in your code, right? I mean, that's a nightmare scenario. So that's very difficult to do. And another challenge here that I think is probably the least thought about is how do you deal with leadership and their interaction with blogs? There is a huge amount of bad information out there. And in addition to that, there's salespeople who are constantly approaching leadership and saying like, hey, you're trying to do this. That sure is hard. I'll sell you this other product that will do it a different way. You don't have to worry about it. And I mean, no matter what you do, there's going to be a type 1 and a type 2 error rate. They just ignore it because they're trying to sell their product. And so we're constantly facing battles where we're like, okay, maybe you don't want to do genetic algorithms to run your experiment on the website. Okay, maybe multi-arm bandit algorithms are not the best way to go. Certain Bayesian methods, we definitely will lean on Bayesian methods when they're appropriate, but there are certainly cases where they're not appropriate. And then, the sort of extreme here is there are even people who are saying like, hey, don't actually sample from the population, just do focus group only studies. And that's incredibly dangerous, right? Because you have no idea if you're looking at a group of people that are all representative of your population, right? What was the study? It was like a survey where it was like, if Roosevelt was going to win and they said that his opponent was going to win, it was like a landslide.
Oh yeah, this was the 1936 presidential election. Yeah, we've actually talked about that before, but this is the Literary Digest magazine, and they sent out 10 million questionnaires, who you're going to vote for, and the results came back, and 53% of the respondents said they were going to vote for Alf Landon, the Republican, and 47% they were going to vote for Roosevelt. And then, of course, the election comes along and Roosevelt wipes him out. He gets like 65% of the vote. And it's all because sample selection. They picked names at random, from their subscriber list, which wasn't anywhere near the 10 million. And then names at random from telephone directories and membership lists from business organizations and professional societies and social groups. The sample was biased.
Right.
It was, and I've often used that as they had 2.4 million responses, and I always tell people that, if the sample isn't random, all a big sample size does is allow you to calculate the wrong answer to a higher level of precision. And a lot of that applies to exactly what you're talking about here.
Yeah.
And it applies to focus groups big time.
Yeah. Because if you imagine taking that, like the absolute worst sort of, reducing to the most absurd situation would be like, hey, let's do a focus group with 12 people and use that.
Right.
So an imprecise estimate of the wrong thing.
Exactly.
So
where you get those 12 people from is
Yeah.
Yeah.
And to be fair, each of those bullet points, there's certainly a time and a place for them. And, we've, focus groups can be great for inspiring ideas, but you need to measure, right? You need to measure, and measuring is not something that focus group does.
I've seen focus groups used very effectively in consumer products industries to try to get some sense of what are the properties of like shampoo.
Yeah.
What do you like about shampoo? Well, I like the fact that it foams up a lot. You get some sense of useful information, but nothing that you can have any statistical rigor connected with at all.
Yeah, and I think we see something sort of similar where maybe it's saying like, oh, card holders enjoy the experience better if X, Y, and Z. But at the end of the day, the job of the experiment is to say like, oh yeah, no, in reality, the population is going to behave this way, up to some error. So, so these are some of the challenges in execution. You know, in terms of, oh, actually, I really like that subtitle. You know, challenges and analysis, right? We're going to talk about experimental 2 units, proxy metrics, and peril. We're going to talk about a fake example to motivate things. Imagine you're talking about an online streaming service. And so, you know, in this case, we're talking about something like Netflix or Hulu or CBS All Access or Peacock or Apple TV or...
Yeah, there's a lot of them.
There's a lot of them. There's a lot of them. Tubi I learned about today. So
I don't even know what that is.
I don't know.
Hey, I got a Roku stick. I can access all this stuff.
Yeah.
All right.
You can spend a good week probably just going through them. So the goal here is we want to attract new customers to the service. But we don't just want any customers, right? Because I mean, there is a proportion of customers that will join and maybe it's like a free first month or something like that, and then immediately cancel. So we want to look at customers that are going to retain their subscription for at least 3 months. So this is what we want to increase, okay? So when we're looking at these customers, you know, we're examining them coming across this sales funnel, right? So, you know, we have all visitors to a website, and then we have visitors who actually see, you know, this experiment that we're running, where we're trying to cause them to sign up with either an offer or just, you know, sometimes it's something as dumb as like a different shade of, you know, green or something that we're trying to use. That gap between all visitors and visitors who see the experiment is made up by things like bots that are hitting the website. If you're using your web browser, sometimes your web browser will actually load content before you click a link. It's called prefetching, so that when you click that link, it's fast. That can appear like a user, right? But it's not anybody. It's not a human that clicked a thing. So we kind of always try to look at this impressed visitors as the number that represents what's the sample that we're concerned with. And then, you know, these users are traveling through the funnel further. They're going to start an application for an account. They're going to submit that application. We're going to confirm payment information. That could fail or it could succeed. And then if it succeeded, we have a customer with an account, but we have to like wait 3 months before we know if they are going to maintain it for 3 months, because we don't have a time machine. And that's a long time. If you imagine you're running an experiment and you're running an experiment for maybe a month or two, to then tell, you know, leadership like, well, we need to wait 3 more months to figure out what the result is. Good luck. So what we need to do is analyze the rate at which people are converting throughout this funnel and use those as sort of proxies for what we really want to know. So users that ended up with a confirmed payment, that number of users divided by the number of users that had an impressed experience, that's a good proxy for, you know, active users that are going to have active subscriptions for 3 months. It's not great, right? But it's good. It's okay. But that rate can be small, and that means that it can require larger sample sizes. So there's a tendency to say like, well, maybe we can just look at users that submitted the application and not even concern ourselves with the payment. And that's almost immediate, right? We know almost immediately that you submitted your application. So we're getting further away from what we really want to know, but the rates are a little bit higher, so we can get away with smaller sample sizes. Maybe we can go ahead with just how many people just started the application. But at this point now, there's a question. Are the users, if you increase the number of users that start the application, does it necessarily follow that the number of users that maintain the application for 3 months will be larger? Spoiler alert, no. So there's a lot to be done along that funnel, decisions and trade-offs to be made. Another problem, we're frequently analyzing users in terms of some demographic information. So for example, you know, users coming to the website, maybe they're coming from a search engine, maybe they're coming through a paid ad, maybe they're a returning customer, maybe it's just organic traffic, right? Each of those we might want to look at separately to see how we're changing those different groups. How are users on the desktop devices behaving differently from tablet and mobile users? What about network? Is network informative? If a user's using high-speed internet versus like 3G versus, you know, somebody who's, I'm assuming in the Arctic somewhere using dial-up, you know, how does that affect things? And then
Those
also,
are your Russian customers in Siberia.
yeah, I would imagine, yeah. Our boss is from Siberia, so
Right. Oh, okay.
it's a lovely place.
Yeah.
It's a beautiful, beautiful place.
Yeah.
Hardware, also, right, is it informative to look at users that are running on older hardware versus newer hardware? Is that informative in any way? Are you worried about tanking the rate on users on new hardware? If you increase the rate on users that are using older hardware, is that something you need to be concerned with? And then location and time. Whenever your IP address can be mapped roughly to a location, they call that this GeoIP mapping. And then when you do the form, you have like a zip code, maybe something like that. We can get an idea for where you are. And then the time also plays an important role. Like if you imagine that someone who is in Phoenix at 3 a.m. on a Monday morning, like they've stayed up all night Sunday playing video games, they're worn out, they're going to the website and they're like, I'm going to get a credit card. Is that different from a person in London who is at work on Monday at 11 a.m. applying for a card? Because that time is the exact same time. It's just a different location. And so, we're trying to account for things like, where are you? What's your time there? What part of the week are you in? What part of the day? Is there a holiday there? What about just regular business cycles? American Express has a lot of products for small businesses. So things like business cycles are super important. And, just to highlight this, these customers are arriving, they're not a simple random sample, right? They're a convenient sample of users who are showing up that we're randomly assigning a treatment. And so being able to sort of account for these different ways of arriving as covariates to kind of help us balance to get an idea for like, okay, well, what's a better idea of what's the population? That's kind of a thing that we need to do, right? We can't just pretend that these users coming in are an actual simple random sample. We have to do a little bit of work. One thing that we constantly run into is this idea that we're going to use a different method to do the analysis because then we don't have to do something that's hard. And so it's this sort of appeal to this black box analysis algorithm. And I just want to highlight any algorithm that you use to make a decision, right? And this could be, you're going to do a two sample test of proportion. This could be, you're going to do, a Bayesian test where you're calculating the posterior probability of superiority of one variant over the other. This could be going down to Miss Rita's office, the psychic down the street here and asking her like, hey, is this going to work or not, right? No matter what the algorithm is, there's going to be a type 1 error rate and a type 2 error rate. And if you don't know that, then you're in trouble, okay? So if somebody comes and says, hey, you can't run this, I know you don't want to run this experiment because it's going to require you to run for 53 weeks or whatever to get the sample size required. Just do this Bayesian method. What are they really saying? They're saying like, let's use a different error rate and not know what it is, okay? So we always say like, you can use whatever method analysis you want, just know what your error rates are. And I kind of, I don't want to come across as though I'm really down in Bayesian methods because, there's a lot of good properties to some Bayesian methods. For example, a lot of the frequentist methods are coming up with this uniform minimum variance unbiased estimator. But that doesn't mean that they're the best estimators. It just means that of the unbiased estimators, they're sort of the best. With Bayesian methods, we can get a biased estimator that has a lower mean squared error, okay? And if we're in a situation where we just need a best guess for a business decision, that might be a better point estimate. Another thing is, that slide before where we have this giant grid of, right, this Cartesian product of all these little things. If you imagine looking at this in an actual traffic report, you'll have very small sample sizes for certain cells in this Cartesian product. And so how do you handle that? Well, Bayesian hierarchical models are a great way to sort of to deal with that and to say like, hey, we want to call out that this low search engine traffic from New Mexico on Samsung browsers is a problem, right? If the sample size is small, imagine the most extreme situation. You have one user, they didn't convert. What's your estimate? Well, the unbiased estimator would be that your conversion rate is 0%. But a Bayesian hierarchical model will say, well, that's not a lot of data. Let's average it with the overall population and, it does some magic with Markov chain Monte Carlo and all kinds of fun stuff. And you get a value that says, well, there's not a lot of evidence that it's very different from the overall, right? And so that can be helpful in terms of making business decisions. Another thing that we're constantly pushing analysts to do is to reconsider the status quo. So, I mean, how many of you are going to run an experiment and think like, okay, type 1 error rate 5%, type 2 error rate 10% or maybe 20%, right? You want 80% power. You'd like 90% power. You're willing to sell for 80% power. Does that make sense in this situation? Well, you know, we mentioned before, the cost of the experiment is front loaded. So in an industrial experiment, if you do the experiment and you get a false alarm and you retool and you retrain, that's pricey. And you just blew a bunch of money if it's a type 1 error. In an online experiment, you didn't really blow any money. You just changed something that didn't have an effect. So a lot of people say, well, we don't care about type 1 errors in online experiments, but that's not true, because the type 1 error is going to be related to how often a negative effect appears positive. And that is the way that the universe punishes us for ignoring type 1 errors. So we have a little table here. If you're willing to allow for a negative effect to appear positive 1 time in 100, then you can actually set your type 1 error rate to 24.5%. And what that means is that your sample size required is only 56.9% of what it would have been if you would have said like, no, it needs to be 5%. Okay, so that's a pretty good savings. And we're constantly trying to push people to be like, hey, this is a number, it's a magic number. A lot of people have no idea where it came from. What does it mean to you? What does it mean to the business? And what should we actually set it to be? Another thing that we kind of try to push people towards is like, what's a good null hypothesis for your test? This is a situation where people feel very comfortable doing the test of, the null hypothesis is that the 2 treatments are the same and the alternative is that, one is larger or they're different. But maybe you want to do a test where the null hypothesis is that there is a difference of some magnitude, and the alternative is that that difference is less than that. The true difference is less than some delta here. I'm pointing at the screen, but of course no one can see that. And so it is so for fixed horizon tests, it doesn't really matter. For a sequential test though, what that means is that you're going to run the experiment and you're going to terminate early when there's not enough evidence of that minimal increase. And the maximum runtime of your experiment, you're going to run the longest time when you're getting that improvement. And it's always a great thing to tell leadership, be like, hey, how about we run the test for a long time, but only when it's actually making you money? They're always on board. Another thing is statistical efficiency. So when we talk about how do you run an efficient experiment, there's like a colloquial idea of efficient, and then there's the statistical efficiency, right? And statistical efficiency is minimizing the sample size required to do the experiment. But sometimes you want to run an experiment where you're maximizing the conversions during the course of the experiment. And that's that response adaptive methods that we were talking about before. You'll have to run the test for longer, but over the course of the experiment, you're getting better performance. You're having better success. That's another type of efficiency. And so, it's important to sort of call that out. Like, what kind of experiment do you want to run? Is it you're trying to minimize the sample size so you can run a lot of experiments and move on and iterate quickly? Or are you trying to just maximize the conversion rate over the course of an experiment because, maybe it's a seasonal thing and it's not gonna have a lot of staying power, things like that. So that's an important question to ask yourself, what kind of efficiency are you looking for in your experiments? And then, I mentioned that there's a lot of bad stuff online. There's 2 books that are actually really good, and that's this Trustworthy Online Controlled Experiments. That's the HIPPO, where HIPPO comes from, right? The highest paid person's opinion. And then this Statistical Methods in Online A/B Testing is also very good. And I have a little asterisk here because, obviously ignore any advice lacking supporting evidence. Some of these are saying things like, don't run factorials because it doesn't make sense because you need a huge sample size. They ignore completely the idea of projection, right? So, it's a developing area. There's a lot going on, but these are definitely 2 really good sources, and you should definitely do a PhD and figure out how to do sequential factorial designs.
Yeah, when you do, please let us know.
And please let us know.
Yes,
Yeah.
I will try to find a PhD student that I can get involved in this.
Yeah.
Sounds great. Yeah.
Well,
Okay.
Yeah, that's pretty
Well,
much it
thank you
for our
guys.
spiel.
I've found this very interesting. I've learned some things. By the way, this kind of experimentation goes on in other domains, not just online marketing. I'll give you an example. I just renewed my subscription to the Wine Spectator magazine, which I read faithfully, and I got a subscription renewal notice that said a little goodie. Another magazine I subscribe to is Sports Illustrated, and they almost always have some sort of giveaway. Like, you know, if you renew your subscription, you will get a Sports Illustrated T-shirt or a Sports Illustrated baseball cap, and I'm a sucker for all of that stuff. I did some consulting work for a credit card company a few years ago, and they were doing these experiments by mail, and they were changing a lot of things. They, you know, what is the introductory interest rate that we're going to give you? How long does that introductory interest rate last? Is there some limit on transferred balances? They had a whole bunch of different things. And then, you know, and then the kicker was if you switch to our credit card, we will send you a free gift, you know, and they had several different kinds of free gifts, you know, and so they've got all of this stuff arranged in, and they were using factorials. They were, in fact, they were using fractional factorials because they had about 4 or 5 factors. And, you know, they didn't want to have to print, you know, 32 different variants of the offer. So,
Sure.
So they were running a fractional factorial. And it was very, very informative because they could mail out hundreds of thousands of each of these combinations of the different offers and get response data back. It was fascinating. They weren't, the big cost in running the experiment to them was printing the different offers because they were going to mail out these offers anyway. So the extra cost in running the experiment was strictly printing, which from their point of view was trivial. So
How did they go about randomizing?
that was one of the big things that I struggled with. They did select names at random from customer lists and other lists that they could purchase. They could get name lists, and they would use that.
Okay.
But I struggled with that. But you know, because there's always this issue. You know, a big non-random sample doesn't necessarily produce a good answer. Yeah. So we have a few minutes left, and we usually devote this part of the Fireside Chat to some Q&A. And we have some questions that came in early, and Megan's been putting this up on the screen. And I'm going to invite Edgar and Anson to sort of chime in on the answers to these as we go along. So this question basically says, could you please share a good open platform-based software which can be used by undergraduate students for free? Well, the first thing that comes to mind is R.
That's what I was going to say.
Yeah, but I hate R.
Yeah, I like it.
I hate it because it requires some programming. And I don't want to teach programming in my course because the concepts are hard enough to learn without having to master the programming. Plus, a lot of organizations will not let you use R once you go to work because they won't let you put open source software on their machine. And then there are regulated industries like pharmaceutical products, food, drug, and so forth. They can't use it because the FDA doesn't certify R as a, and then finally, there's the last thing, who wrote it? Who wrote it? How do you know whether they know what they're doing? How do you know whether it gets the right answer? I mean, so I have a big problem with this. What I always tell people to do is to explore the possibility of site licenses at your organization for packages like Minitab and Jump. They also have packages, student versions that are very inexpensive. And you can also download trial versions for free. You guys have any other suggestions?
Well, you know, R is been approved for use at American Express.
It has,
which is nice.
So that's probably the tool I utilize. the most,
good.
but,
And you know, we like to use Jump, but Jump is one of those pieces of software that when you tell people how much that's going to be, they're like, okay, R seems a lot better.
yeah.
And then you get into these weird situations where the question is, why is the answer different in Jump than it would be in R, or well, actually any software package, and you get into some real weird details about coding and that kind of stuff. But I you know, honestly, given the size of American Express and the broad number of groups that have analysts that are trying to do this kind of thing, R has been very helpful for us. There is a question, of course, with any kind of package. You know, is it, you know, written as a practical joke, or is it real? And you know, honestly, we do a fair amount of work running some sophisticated simulations to make sure that we're getting the nominal error rates that were expected. And so we kind of put things through their paces. But yeah, in terms of something that's for free, you know, R is good. And then if you can get the free trial for Jump, I mean, that's going to just be a lot easier and help you get to the answer faster. With fewer moments of consternation of why is this sample size, or why is this effect size half of what it should be, or
Well, and for students, usually there is a way to get access.
Yeah.
Because most universities do have site licenses for some of this software. If your university has a site license for SAS, and it would be hard to believe that most places wouldn't, then tacking Jump on there is low cost.
Yeah.
And it's worth doing.
And companies like American, you know, at American Express, we do have, there's a group that uses SAS a lot.
Right.
So, you know, it's definitely whatever tool you use, if you're at an organization that's as large as American Express, you'll be able to take that knowledge directly into how you use it.
Right. Yeah, I can remember some years ago when I was a faculty member at Georgia Tech, I was teaching an advanced course on experimental design, and we were looking at methods for analyzing unbalanced factorial, large unbalanced factorial designs. And there was a particular software package that we had access to. And I discovered that with a lot of detective work that the documentation said they were using method, let's call it method A, to do the analysis. And when you dug right down into it, it turns out they were actually using method B, okay? And the bad news is they were doing method B wrong. So,
yeah,
you know, you really have to be kind of careful. And when it's, you know, when it's free, you know, the old joke is, well, when it's free, you get what you pay for. So you have to think about that. So here's another interesting question. I want to ask you how to determine the fraction in fractional factorial designs. It could be a half or a fourth or an eighth. How do you decide this? Well, I think you have to look at what I call the sparsity of effects principle. What do you expect to be important? Well, you expect to find main effects and maybe a few two-factor interactions. So that leads you to think about maybe resolution 4 designs, maybe resolution 3. Here's a case where they've got a lot of factors, more than 10 factors, and this is a real problem because 2 to the 10 is a big number, and 10 factors in 16 runs is a resolution 3 design. And that's going to give you information about main effects, but that information is going to be confounded or aliased with two-factor interactions. This is a scenario where I think that you need to think about using non-regular designs, Plackett-Berman designs, for example. I would think about 10 factors and maybe a 20-run Plackett-Berman design, or maybe 10 factors and a 16-run no confounding design of the type that we've talked about a little bit in the book, and that Carly talked about in her Fireside Chat appearance a couple of weeks ago. So I think you have to look at what sort of information do you expect to recover from the experiment? And with up to 10 factors, you're probably going to be doing sequential experimentation anyway. You're going to learn some things from the first experiment, and you're going to do a follow-on experiment to get more information about how those factors work together. Does that make sense, guys?
Oh, yeah.
Yeah,
So-
okay. What are application areas of designed experiments?
Oh, can I answer this one?
Yeah,
Everything.
yes.
Okay.
Yeah. Better to answer the areas of non-application, which are not, well, I don't know, religious studies, maybe?
Miss Rita, again, down the street. I'm really plugging Miss Rita hard.
Yeah.
Yeah, she's the local Swami around
Yeah,
here.
she does she's the psychic down the street, and I
Tarot
don't think
cards.
she doesn't run a lot of experiments.
Maybe she does though. You don't know.
Yeah, I
We,
don't know.
we
Maybe.
don't know.
Maybe.
Maybe she can do some consulting. We can do consulting for her.
Yeah,
Yeah.
you never know.
We'll go check her
We'll
out.
go after this. We'll go do that. Yeah.
Okay.
How do you apply experimental design in manufacturing with lots of variations? I'm going to call that variables. Maybe that's what we mean here. I think it depends a lot on the type of manufacturing system. If it's a single process, like a large-scale machine of some kind, I think you follow the same advice that we just talked about earlier. You know, you think about fractional factorials. You think about maybe resolution 3 designs and sequential experimentation, or you think about non-regular designs. If it's a sequential manufacturing process where you have like semiconductor manufacturing, where you have tool after tool after tool after tool, typically what you do is you concentrate on each individual tool, and you run experiments at each tool, and try to I call those characterization experiments. What is it that makes this tool work? What factors are key in looking at the variability in the output of that machine? And fractional factorial designs are a classic way to do characterization experiments. What do you think, guys? Does that make sense?
Yeah.
Here we go. Question for you guys.
So the question is, do the online tests target American Express customers and not non-American Express customers? So yeah, we do have a lot of tests targeting prospects, like, you know, say for a card application or personal loan, something like that. And we also do run a lot of content experiments for card members, right? So for people that are using the app to, you know, manage whatever they happen to be, we run a lot of experiments to kind of optimize that app or to optimize that journey. Is that kind of what they were going for?
Yeah.
It's sort of like the subscription to the Wine Spectator.
Mm-hmm.
You know, the only people that are participating in that experiment are people who are already subscribers.
Right.
Yeah.
And they're trying to incentivize you to renew early, so they get their hands on the money, and they keep their subscription base up,
Sure.
and they incentivize you by giving you a couple of free issues.
I think American Express is also a little bit unique in the sense that there's a lot of partnerships with other businesses.
True, there are a lot of co-brands.
And so what you'll find is that sometimes you'll do an experiment where, you know, we start off the experiment and we hand it off to, I don't know if this is true or not, I'm just going to say Expedia, because travel is a big portion of American Express's business. And so that's sort of another interesting aspect, is how do you coordinate an experiment through different organizations, different systems altogether.
Right, from a data perspective, a lot is lost in that handoff, right? Like once we pass it to that external organization, we lose some information that would be valuable. So.
New question. Do we change the ultimate success measurement units to save time and reduce the required sample size?
Yes. Should we? Probably not.
Right. But yeah, kind of like Edgar was talking about earlier, right? Where we just use different proxy metrics further up the sales funnel, I guess, right? A lot of times that's to accommodate feasibility constraints, right? Like, hey, we can only run this test for 8 weeks due to, you know, whatever restrictions we have in place.
Sometimes it's even
but when you do that, that affects the error rates.
Exactly.
Yeah.
Right.
And you have to balance, you know, all of that.
Right. And keep in mind, when you're doing that, you're making inference on the those particular rates, right? Connecting it to the ultimate metric that or connecting it to your primary metric isn't always straightforward.
Right. Good question.
Please repeat.
Yeah, so can you define projection in the context you previously discussed? So we're just talking about sort of the standard, factorial definition of projection, where, there's certain factors that are not significant, you remove them, and now you have the factorial of a smaller degree with larger sample sizes.
Yeah, a classic example would be a 2 to the 4 factorial. It's a 16-run design. Well, if one of those factors turns out to be unimportant, then you can drop that factor, and now what you have is a 2 to the 3, but you still have 16 runs. And so you now have 2 runs at each corner of that cube.
Right.
And every 2-level factorial design, or fractional factorial design, possesses these projection properties.
Right.
And this is a very, very powerful way to really utilize these designs that a lot of people just don't understand. We talk about, this is discussed a lot in the textbook, and it's also discussed in the portion of the course where we talk about factorial and fractional factorials. This is course number 2 in the array. Okay, so that is the end of our questions that we have. We're coming to the end of time. We try to hold these fireside chats to an hour, although we could go on forever.
Oh, yeah.
There's this.
Miss Rita's projection is different. Totally, we could talk about that probably.
Yeah, we could do that.
Yeah.
Yeah, that'd be very. I should think about having her as a guest possibly.
Yeah, maybe next month.
Yeah, maybe a guest. Well, we've got some interesting guests lined up. Just a quick minute. One of my colleagues, Dan McCarville, and I are going to talk about running experimental designs in wine blending next week. Aha. And then I've got Brad Jones from Jump lined up as a guest. I have Dr. Stu Hunter, who is one of the most famous people in the world of experimental design, lined up. And also a colleague of mine, Steve Rigdon, who is an expert in designing reliability experiments, things like life testing and accelerated testing, things that we don't really talk about much in the course, but he has a lot of experience in this area, and I think he's going to be a fascinating guest as well. So thank you for coming, and I thank my guests, Anson and Edgar, for coming and doing such a great job. This was very informative, and see you next time.
See you guys.